Okay, we've talked about correlation. Now let's move on to regression. Now regression is where you actually, you think there may be a straight line that goes through the data, and we're actually now going to use it to predict y values from x values. So it's directional. Okay, we're using an equation like this. X is the one that we are putting into the formula, and y is the one we're trying to predict values about. So that means the variables don't have the same role. So earlier on in your notes, this is kind of slightly out of sequence. There was a distinction between x values and y values. So back to this section here, controlled variables. Okay, well, there's different terminology here, but the idea is that maybe now we are starting to think that x is causing changes in y. At any rate, we're going to be using values of x to predict the values of y. So on the x-axis, we have the variable that we are maybe setting the value of, and therefore we control it. Well, if we call x the control variable, then y is called the response variable, because as we change x, we expect to see a response by y changing. Or sometimes you see y called the dependent variable, and in that case, x would be known as the independent variable. And you are expected to know all of these words. So find this page in your notes and add them now. Okay, and the comments on this page are absolutely correct. Okay, it makes sense to try and predict marks in the real exam based on the mark in the mock exam, because this one's coming first, and this one is coming later. It probably doesn't make sense to try and predict the other way round. Here we expect genuine causation. The amount of fertilizer we put on the plant may actually cause the amount of growth we get. So we'd have this as the control variable, and this is the response variable. And it makes sense to predict the height of use the height of the father as a predictor for the height of the son when he gets older, because any causation would be this way round, not the other way round. Okay, so really important you know this terminology. And this is a kind of very basic question you could be asked. We've just got a table of data, and we've got to find the equation of the regression line. Now, once again, on page 5, not page 17, page 5 of your formula book, you do have this formula here for B and this formula for A. So A and B are the unknowns. X and Y are going to still be X and Y in our equation. We need the values of A and B. Okay, now you can use these formulas, and I'll show you how to do it on the example, but you're expected to do it on your calculator. So of course we need mode 6 for statistics, and of course we don't want one var mode, we want mode 2, because we're using exactly this. Notice the actual regression equation we're using is precisely option 2. So we put our x and y values into the table of data. There we go, and as before, we press the option button, and as before, we go to regression calculations. And in fact, I think we've had this data in a previous example. I recognize that value of R, but this time it's A, which is 3.642, and B, which is 0.9405 that we need to record. So that's great, but just supposing they hadn't given me the table of data, but then given me these funny things here instead, then I can find B by doing SXY over SXX. Here it is. Notice that now is not a symmetrical formula. It matters which way round X and Y are. So SXX is on the bottom, so the X data, okay, is being used on the x-axis, so that's how I choose that one. So that's why it's a 42 on the bottom. Okay, do that division, and guess what? You get 0.94048 again. Okay, and for your A, well, the formula for A is y bar. Okay, and I'm told y bar is just the mean of the y values, as you'd expect. So that's going to be 7.895. Okay, minus B, 0.94048 times my x bar times 4.5. Okay, now if you round this value here that you've put from B, then you'll get a possibly an accurate value of A. So it's a good idea, if you're doing this method, to keep this value to all its significant figures, multiply it by 4.5, subtract that from 7.875, and of course you will get 3.6429 as before. If you get a slight difference here, it's because you did some rounding. Okay, so that's how we get A and B, and that's where I'm going to end this video. But the most interesting one is the next one, where we actually put this regression into action and we do some interpretation.